Okay, so let us just start the session now. Uh, Today's session is on week two. Okay, so is my voice clear?
Yes, sir.
Okay, so in week two, we have determinants. Determinant part three. There are some properties of determinant. I think most of the properties are already covered. Okay, and after that we have Kramer rules, and then we have solution to the system of linear equations with the invertible coefficient matrix. Okay. And after that we have echelon form, and this echelon form is used actually to find all forms of solution. Suppose a system has infinite solution, then we can by using actually Gaussian elimination method, which uses echelon form. So that's why echelon form is important. Okay. So I can I assume that you all know the concept of week two. I mean, not entirely, but just you have watched the lecture or instructor session.
Sir,
Everyone? Yeah.
sir, my problem is in row echelon form understanding and its concept.
Okay. Okay. Curriculum form I discuss. Okay.
So I have doubt in activity 2.2 question number 4 and 5.
Okay. So first, after explaining the echelon form, I'll move on to the doubts. Okay.
Oh, okay.
Okay. Okay. So you can see my screen, right?
Yes, sir.
Yes.
Yes, sir.
Echelon form. So, so obviously, it actually uses a matrix. Okay. So there are certain properties that should satisfy in order to be a matrix in echelon form. Okay, row reduced echelon form. Okay, so there are two things: row echelon form, and there is one more condition that is not necessary. That is necessary only for a row reduced echelon form. Okay, row reduced. This term reduced actually. Stands for reduced. Okay, there is one more condition. So what are the conditions? So first condition is leading entry in every row must be one. Okay. So what is leading entry? First, leading entry is the first entry. Okay, in every row. So suppose there are three rows, then suppose this is a three by three matrix. Okay, then the first entry in every matrix is the leading entry. First non-zero entry. Sorry, what is leading? First,
Sir, first
no,
from left or right?
from left,
Okay, sir.
non-zero entry. So what is leading entry? First non-zero entry. So in first row, obviously first one should be one, and in second row, uh, second entry. So then there are further conditions according to that. Let me write all the conditions first, then I will explain. And so what is the second condition for row echelon form? Anyone knows?
So can you repeat again what you said, if you don't mind?
Yeah. What is the second condition that should satisfy in order to be a row echelon form for a matrix? So leading entry. So second condition is a leading entry in the next row uh, should be in right. from the previous row. Okay, so suppose here it is 1 and there are some values. Okay, so this is a 3 by 3 matrix. There is 3 by 3 matrix, so there are two more entries. Then in second row, this entry must be 0. Okay, and after that, leading entry can be here or here. Okay, okay, so suppose here, and then in the third row, leading entry, this entry must be 0, this entry must be 0, and this can be 1 or may not be 1. So basically, if there is a leading entry, then suppose leading entry in this row, second row, is in the right of the leading entry of the previous row. Okay, clearly. So
So to
this
say
is
it is like a upper triangular matrix only.
yes, yes. Okay, so upper triangular matrix, but this condition leading entry concept. Okay,
Oh,
and then third condition is if any zero row, that should come last. Okay, and fourth condition, that is actually just important for this RREF. This is every entry in a column, every other entry. Okay, every other entry in a column uh, from except a leading one should be 0. Okay, so these are the conditions. So whoever has doubt in this curriculum form, just give me an example so that I would make a matrix in curriculum form. Just any example that you are facing difficulty. Hello.
Yes, sir.
Yeah. So you have doubt in curriculum form, right? So just give me an example so that I can actually convert this into curriculum form. This matrix. So just tell me the first row.
Sir, 2, 5, 6.
2, 5, 6. Okay. A 3 by 3 matrix or 4 by 3 or 3? Any other
Sir,
order?
sir, 3 by 3. First,
Okay.
start
2.
with 3 by 3.
Yeah. Okay. 2 by 2, 5, 6, and
Sir, then 1, 3, 2.
okay. You are telling randomly. Okay. That's
Yes,
also
sir.
fine. Okay.
Sir,
So
9, 10, 11.
9, 10, 11. Okay. So, so what is the first condition? That leading entry. So in the first row, this should be the leading entry, right?
Hmm.
So it
Yes.
should be one. It should be one, but there are already one in the second row. So we can just switch. So what are the operations that are allowed? We can switch any two rows. We can multiply a row by a constant, or we can add a row into another row after multiplying any constant. Okay, maybe one.
Okay, sir.
Okay, yeah, these are the three elementary row operations. Okay. So I'm applying the first operation, interchanging the two rows, 3, 2, and 2, 5, 6, and 9, 10, 11. Okay, so what operation I have applied here? Row 1 interchange to row 2. Okay,
Yes.
so I got the leading entry. The condition is satisfied, first one. Now this entry must be 0, right?
Yes, sir.
Okay, so this
Below,
entry,
below
yeah,
1.
below 2, this should be 0. So for that, what can I do? I can take row 2 and minus 2 times row 1, right? So in
Yes,
that
sir.
case, yeah,
Yes.
this would be 0, this would be minus 1, this would be 2, right?
Yes, sir.
9,
Yes.
10, 11. Okay.
11.
So we got this also. Now this entry also should be 0, this 9, right? So for that, I'll take row 3 and minus 9 times of row 1. So So what would happen in the third row? It would be 0 and 9 times then 27. So 17 minus 17, and then 9 times is 18. So 7 minus 7. Okay, 0 minus 1, 2, 1, 3, 2. So now you can see this is the leading entry, and below that every entry is 0, right?
Yes, sir. Sir means
Okay.
in the first column we have got the row echelon form.
No, no,
Matlab,
no, 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 no. There is no concept of just first column. Uh, entire
sir
matrix.
means
Row echelon form is for entire matrix. Okay.
yes, sir means first step is done.
Yeah. First step is done basically. Now you can see that this is the leading entry column.
So
Okay.
in this,
Yes, sir.
excuse me, in this first row, you have interchanged and multiplied by 1, right?
Hmm. First I interchange the first row with second row. Then I apply row 2 minus 2 times row 1. And why I am doing this? To satisfy these above conditions that I written. That
Sir
there should
means
be. Hmm.
sir means we have to bring one and then double zero in 3 by 3
Uh,
matrix in first
yeah,
column.
yeah, that is okay, but just don't try to learn these things, that one and then 2 0. We are satisfying these conditions basically. There should be leading entry. What is leading entry? The first non-zero entry in a row. So this is the one condition, and then every leading entry, suppose this is the first leading entry. Now when we create leading entry in the second row, it should be to the right of the previous leading entry. Okay, this is the second condition. Okay, and if you satisfy these two conditions, then it would be enough, because if you got any zero row, you will just put that row to the last of the matrix. Okay, so basically, these two conditions you have to take care. You have to create leading entries, and the leading entry in the next row should be in right of the previous leading entry. Okay. So
Yes,
yeah. So now we have created this leading entry. Okay. I mean,
yes,
why I am calling this leading entry? Because this is the first non-zero value. Because this is the first actually. So basically, it is non-zero, right?
Can you please explain the
Now,
second point once again? I couldn't understand
what is the second point?
that it should be the right first.
Yeah, I'm just doing, then I will explain. Okay.
Okay.
So yeah, first this is leading entry. This is because this is non-zero. Okay, and leading entry should be 1. This is the first condition. So which is here, it is 1. Okay. Now the second point is a leading entry in the second row should be right of the previous leading entry. Okay, that means the leading this below in the second row, this
second
and
law is second row and second column.
okay, so this entry cannot be 1, cannot be non-zero. Okay, this I circled because of the first condition, or because of the second condition. Okay, and this also cannot be non-zero, because leading entry in the second row should be in right of the previous leading entry. Okay, this is the second condition. So now take the second row and make a leading entry, which is non-zero, or leading entries must be 1. But here it is -1. Okay, so what we do, we take second row, and we would multiply the second row by -1. Okay, we can multiply any row by constant. This is the second uh, elementary
Yes,
row
sir.
operation. Okay,
Yes.
so when we do this, second row will be like this is 0, this is 1, and this will be -2. And this is 1, 3, 2, and this is 0, -17, -7. Now see, is my second condition satisfied? Second condition says, uh, so suppose first is there is this leading entry in the first row, this is the leading entry. And now in the second row, what is the leading entry? This one,
Sir,
right?
This
Zero.
one.
So one.
yes,
Because
sir.
why this is leading entry? Because this is the first non-zero value in this row. Okay,
Yes, sir.
So
Okay.
so that, yeah, so that's why this is, and condition says leading entry must be one. Now it is one. Okay, so now we can call it, this is leading entry, this is leading entry in the second. Now in the for the third row, this cannot be leading entry. This cannot be non-zero. Okay, this entry cannot be non-zero. Okay, so for that, what we do, we make it zero. So how do we do this? We take this third row, row three, and we add what we add. We add 17 times row two. Okay, so what we get here? So 0, 70 times 0 plus 0, 0, and 17 times this would be 0, and then 17 times minus 30, minus 34. Okay, minus 34 and minus 7. What would be?
41.
Minus 4. Minus 41,
Minus
right?
41.
Okay, so now this is 0, this is 1, this is minus 2, this is 1, 3, and 2. Okay, so yeah, so now this condition is satisfied that the below the value below the leading entry, there is, this is 0, right? So this condition is also satisfied. Now what is the leading entry in third row?
Minus 41.
Minus 41, but condition says
Minus
it should
41
be,
should change to 1.
yeah, it should be 1, leading entry should be 1.
Yes.
So for that, we will divide this by minus 41. Okay, so what
Yes.
will be the final matrix? 0, 0, 1, 0, 1, minus 2, 1, 3, 2. Now you can say, this is actually, so we can say this is the row echelon form. Okay,
Okay,
all
sir.
the all, so just let me verify whether it is a row echelon form or not. Okay, so first condition says, uh, leading entry or first non-zero entry, okay, that is the leading entry in every row must be 1. So, okay, so what is the leading entry in first row? 1. Okay, what is the leading entry in the second row? This is 0, so this is the leading entry. Okay, it is 1. What is the leading entry in, so this is non-zero, non-zero, this is the first non-zero value, and which is 1. Okay, so first condition satisfied. Second condition says every leading entry in the next row should be right of the previous leading entry. So previous leading entry is this, and this is to the right of this. Okay, this is the next leading entry which is to the right of the previous one. Okay, second condition is satisfied. What is the third condition? If any zero row, it should be in the last. There is no zero row. Okay, no problem.
Excuse
What is
me,
the,
sir.
yes?
Sir, I'm trying
Yes.
to access my recorded class for this, but it is not giving me access.
On YouTube.
Yes, sir.
Okay, you on YouTube there is no kind of access provided. Everyone can watch those videos, right?
Can you paste the link in chat?
So we also don't have access of
Hmm?
Just search
TA
just
session
search
for what we learn
IITM.
for.
Just
Hmm?
search IITM Maths 2 Data Science.
Yeah, you can actually open YouTube
Now
channel.
then you can see.
You can open YouTube channel and then just go to this ITM BS degree channel
Okay, sir.
home
Now I
page.
have access. Thank you, sir.
Okay. Okay, so we are checking these conditions for row echelon form. So yes, these are satisfied.
Sir, can you
Now,
please repeat the second rule?
second rule is just this, leading entry should be in right of the previous leading entry, right side of the previous leading entry. So yeah, clearly. Okay, this is the second rule.
It's the right side of the previous leading entry.
Previous leading entry.
Okay, so that is for the second row or the third row, right?
Yes, yes. So okay, so this is the row echelon form. Now, what is rho reduced echelon form? RREF. For this, every column, leading entry column, should have all the values zero other than the leading entry. So in this, yeah, this is leading entry, and all rest
Sir
of the
means,
values are,
sir, sir means
yeah.
in this matrix, in the last matrix we have done that second row, nahi sir, second column, first row and third column, first row, there is 3, 2 and -1. So therein should be those number.
I don't get it actually. What you are saying? Okay, so
Sir
just
means they are
let me complete the fourth point. I think your doubt will be clear. So
okay, sir.
fourth point says in for converting RREF, except the leading entry, every other entry should be zero. Okay, so this is first column is satisfying that, and in the second column, this is non-zero. Okay, because this is the leading entry in the second column, and this is not the leading entry, and it is non-zero, but it should be zero. So for that, we further apply the operation so that this is also zero. So for that, what should we do? Uh, Definitely, we are gonna change the in row one, and we will minus 3 times row 2. Then what will happen? This is 1, this is 0, and 3 times and minus. So basically 8, right? And 0, 1, minus 2, 0, 0, 1. Okay, yes. So now, except the leading entry, all the entries are 0. And then now, in this third column, leading entry is this one. So these two entries must be 0. So for that, what we do? So for this one, we take this R1 minus 8 times R3, and we get 1, 0, 0. Okay, and for this one, we apply root 2 minus, or minus, we can say plus.
Plus
Okay,
2 times of row 3.
root 3, and 0, 1, 0, 0, 0, 1. So do you
Now
know
it is the
what
identity matrix.
identity matrix of 3 by 3?
Yes.
So what we are seeing here is basically RREF of every matrix is this. Okay. If it is convertible into identity matrix, otherwise, what it could be? It could be like 0, 0, and then 0, 0, 1, and 0, 0, 0. Okay, this also could be possible. Okay, and or what can it happen, because this row is 0, or what it can happen like 0, 1, 0, 0, 0, 1, 0, and then 0, 0. Okay, this is also possible, or there are other possibility. Basically, this kind of matrices we will get if it is a full rank matrix. Okay, what is rank? You will see later. If it is a full rank matrix, then definitely it's going to be identity matrix only. Or full rank, for now you can assume a full rank means if it is a 3 by 3 matrix, then this rank could be 3 maximum. Okay,
So these two are also row echelon form or what, sir? 1 0 0 0 0 1 0
yeah,
0.
these are all row echelon form actually. So I just wanted to ask you this matrix, about this matrix. Okay, all of you. So do you agree this is row echelon form? Okay, let me take a different example. Okay,
Yes.
this is also row echelon
Maybe.
form, but I'm just taking different example. 1, 0, 3, 0, 0, 1, and 0, 0, 0. Okay, so can I say that this is row echelon form?
Yes, sir. Yes,
Yes.
sir.
Okay, so can you tell me what is the leading entry in the first row,
1.
1,
1.
and what is the leading entry in the second row?
0.
That's 1.
This
0.
one. So see,
Okay, one.
so it is not necessary that it should be like next leading entry should be this one. It is not necessary. Basically,
Sir,
leading entry is the first non-zero entry. Okay, so
sir
first
means
non-zero entry. Yeah.
sir in between there maybe some zero column.
Yes.
Okay.
Maybe. Basically, there are just three conditions. So that's what I'm saying. So there are non-zero entries clearly, and this leading entry is right side of of this leading entry, right?
Yes.
So these are the conditions for regular. This is very simple. And that's it.
And in third row, there is no one, right? So that doesn't matter.
Yeah, there is no leading entry.
Sir, if like in case in the second row, in only in the first row we have elements 103, and in the
Hmm.
second row and in the third row all are zero, then is it REF or
Yes, yes, yes.
then also?
Basically, it is yeah, because it is satisfying. How leading entry is one, yes, and if there is any zero row, it is come to the last. Okay, yes, they are in the last, so it is satisfying. Okay,
And both second row and third row are also zero, then also it will satisfy, right?
yeah, also still
Okay.
because condition says if there is any leading entry, it should the right side of the previous leading entry. So if there are no leading entries, okay,
So one question. Sorry
yeah.
if you would have already mentioned that. Just wanted to check if you are going to do activity questions today, or is it just concept today?
Uh, okay, actually, if you guys don't have any other conceptual doubt, because somebody asked that about row echelon form, that's why I explained. Then I will explain the activity questions now.
Okay. So can I just mention you what activity questions I have some doubts on? I'll not be able to attend this session. I'll have to jump onto another meet. So can I just mention so that I can watch later point in time today?
Okay, so okay, let me write them. Then in that case, yeah. Then
2.1 activity questions 2.1 on that question number 9
any other?
and another one is 2.5 question number 8.
Okay. Is there any other question?
No, this is all. These are the two. Thank you very much.
Okay. Okay. I'll keep them. Okay, so now anything else? Anybody has any doubt in any concept? Anything in week two? And then I will solve question.
Yes, sir, in activity question, sir.
Okay. Okay, so before that, I'm just confirming from everyone.
So
No
like,
conceptual doubt, right?
RREF is only the last topic in week two.
Gaussian elimination, I guess.
So we'll be doing that, right? Today.
Okay. Okay, so first, because most of the students are asking about activity questions, so let's solve them first, and then after we have time, we'll see Gaussian elimination method as well. Okay. Yeah. So 2.1 question is question 9. Okay.
Sir, question number
Sir, please
5.
explain question 8 also.
Sir, question number
Okay.
5. Just
Okay. Question number 5 first.
sir, here
So A.
AIJ means what is this? Can you just brief it? Then I will solve. Actually, unable to understand this all this.
AIJ is the actually uh, base square matrix. So Aij is the value. Okay.
Yeah.
And what is Aij? It is given there. Where Aij is I, find determinant of A. So okay. Is it related to any other question? No. So basically Aij means
Aij means row and column, but here Aij
Yes.
equal to Y. How to proceed it? This question I am not understand.
Okay.
Yeah.
So
See,
the
the
values are
first.
based on
uh,
the rows, sir, because it is given that Aij is equal to I. So for every row, the value will remain same. For first row,
yeah.
it
So
will be
for
1.
okay. So first of all, this is a 3 by 3 square matrix, right? It is
Yes,
said,
right.
I think. Yeah, 3 by 3. So every entry when we fill out, so Aij equals to I. That means what is I for this one?
For
One,
first row, it
right?
will be 1.
First row, it
Uh,
will be 1.
I is row number and J is column number.
Column number.
So
Yeah.
so for this value, row number is 1. For this row number is 1. For this row number is
1.
1.
Then
And for
row
this row
2,
number is 2.
2,
2, 3,
3.
3. Okay.
That's all.
Now you can find that now whoever asked, you can find
Yes.
the determinant of that, right?
Okay. I
Well, yeah.
will.
Can you directly tell what is the determinant?
Just minutes.
Sir,
Sorry.
0.
Zero.
Yes, because rows are same, so determinant is if any two rows are same, the determinant is 0. Yeah, next question.
Equal to question number, sir. This 7 here. A equal to C1, C2, C3, 8.
Eighth
Yeah,
one, sir.
Below, sir.
you this question number 8.
Yes, sir.
A is a 3 by 3 matrix as given below, and so C1, C2, C3 are columns, right? Because it
Okay.
is given here, Ci represents the ith column of a matrix A.
Okay.
So because it is a 3 by 3 matrix, that means C1 is a 3 valued vector, right? C1,
Yeah.
and C2 and C3 also 3 valued vectors. Now let us consider the following set of matrices. So using these columns, we have made some matrices. Okay, and now we have to tell which of the matrix have the same determinant as that of A. Okay, so I just told you in the I think some session, previous session, that we can apply some column operation on a matrix when while finding the determinant.
Yes, sir.
In some cases, determinant remain unchanged. So there are three properties I told you. So which property actually says that determinant will be unchanged?
Sir, can you please explain that rule again?
Yeah. Okay. So rule is if we
Row and
take
column.
if we take
If you
any
add, if you add in a row,
if we yeah, if we take any row or column,
yeah.
anything, okay, and add that to any other row or column, or after multiplying some scalar also. So t can be 1, 2,
Yes,
3,
yes.
any scalar, okay, any real number, okay, any real number, even 1 by 2, anything, any scalar, we can add that, then determinant remain unchanged. Okay, so what is the meaning of this operation? Suppose in this, I can take the second row and minus 1 times the row 1. So what would happen? Here we get 0, sorry, 2 times. So what we get? 0, 0, 0, right? 1, 1, 1, and 3, 3, 3. Is that clear?
Yes, sir.
Okay, so finding the determinant of this or this, see, okay, no problem after applying this operation. So this is the, so basically, so this operation I applied on row. We can apply it on columns as well. Okay, so here it is applied on columns. So what is happening here? In the A1, we are taking a column 2 and adding 5 times of column 3. Okay, no problem there. Yeah, so A1 will have the same determinant, right? Is that clear?
Yes, sir.
Okay.
Then A3 also. Oh, even
Okay.
A.
And yeah, and then in the second A2, we are taking column 2, okay, and adding column 3 here. Okay.
Yes, sir.
Oh, sorry. We are taking column 1 and we are adding column 2 and column 3.
3.
Okay, and then column 2, column 3 as it is. Okay, so no problem in negative.
So please write
Okay.
on the screen what are you saying.
But in A, sir, A4, here also we are adding C1 plus C2, C2 plus C3, C3 plus C1.
Okay. So in that case, I have to actually take this screenshot of this. So
Sir, I have
what I
doubt in practice assignment, sir. Seventh
yeah,
question.
yeah, let me solve this one. Okay. So first one is clear, right? Who asked this? First one is clear to everyone. Why this
Yes,
is
sir.
true?
Yes, sir.
Okay.
Got it.
Okay. So for second one, I what I'm doing is I'm taking
So please explain first one also.
first one is actually this. There are three columns, right? This column one,
Yes, sir.
this is column two, this is column three. So what we are doing, we are taking the second column, okay, and we are adding
Yes.
this column also in this, okay, and this column is as it is, this is as it is. So we can do this, okay, as we do with the rows, we can do this, right? Determinant will be unchanged.
We add second or third column.
We have added third column in second one.
Oh, okay. Okay, sir.
Sorry, 5 times of the third column in second one.
Okay, sir.
Okay, 5 times of the third column in second one. Okay, this is
Okay.
okay. So yeah, this is applicable. So for the second one, what we have done first, uh, we have added column one plus column two, okay, and column two and column three as it is. Okay, still the determinant will be unchanged, right?
Yes, sir.
And now we have taken this, taken this and added into this one, C1 plus C2 plus C3 in the next step, and C2 and C3 are as it is. Still determinant would be unchanged, right?
Sir,
So
can you solve this sum by one simple example?
Sir, here A4, can you explain this? Why here not determined is?
okay, so in A4 what is happening here, suppose we have applied this one, C1 plus C2, and
Yes.
now C2 and C3 as it is. Okay,
Yeah.
this is okay, and
Yeah.
now here C2 plus C3. Okay, so we can apply C1 plus C2. We can add this third column in the second column, C2
Okay.
plus C3. No
Yes.
problem here. Now problem is here. How there is no column 1, so there is now column 1 plus column 2. So how would you add C3 plus C1? Because there is no C1, there is C1 plus C2, so you have to add this also.
Okay. If we add C1 plus C2, then it will be 0. Otherwise,
Yeah, not 0, it will be determinant would be same as A.
yeah, yes, yes.
Okay,
So why
but
we
here
can't directly subtract?
yeah, we can subtract, so
Means in
yeah, just
column
tell
1 minus column 2 minus column 3.
column 1, okay, column 1, this one, then column 1 minus,
Column 2
I mean this, okay, column 2, then we
minus
get
column 3.
C1.
C1 plus C2 plus C3 minus C2 minus C3.
First we are saying column 1 minus column 2, right?
Yes, sir.
So when we take this column 1 and minus column 2, we get C1 minus C3, right? Is that fine?
So we are applying this
Okay,
in A2, no?
uh, this one, right?
Yes, sir.
Okay, so this one I have applied. You are saying column 1 minus column 2. I applied, and where column 1 you are changing column 1 or column 2?
So which option you are saying? मतलब A2 solve कर रहे हैं?
No. We can apply one at a time. Okay, we can
Yes, sir.
apply one operation at a time. This is
Yes, sir.
clear.
Yes, sir.
Yes. So
Okay,
yeah.
okay.
So now just tell me. So these two options are correct, right? You got it. Why this is true,
Yes.
right?
Yes, sir,
Yes,
I
sir.
got it.
Yeah.
Sir,
Now you have doubt in A4, right?
Yes, sir.
Okay, let's discuss A3 also first. So in A3, this is C1, and okay, this is C2, and we have added 5 times C3. Okay, that is also fine. So in the second step, I'm explaining A3. Okay, here. So in the second step, what we have done, C1, C2 plus 5 times C3, and now C3. Now to get this one, how can we get 0? There is no C3, not here, not here. How can we subtract and get C3? No, no way, right? So that means this is a different matrix. Okay, uh, basically different thing which has determinant different than A. Okay, so this is the third option. Now fourth option. Why fourth option is not true? So fourth option, first we are applying C1 plus C2 and C2 C3 as it is. In the second step, we are taking this column and adding this one, and then we are getting this one, C1 plus C2 and C2 plus C3. Okay. And now to get C3 plus C1, is there any way we can get C3 plus C1?
no.
No, basically. Okay, because these columns are changed. So that's why this is also not true. Okay. Now this is the one way, uh, which is quite difficult, or maybe you are not sure whether this is true. Let's go other way. Okay, backtrack, reverse basically. So I'm taking the fourth one, C1 plus C2, C2 plus C3, and C3 plus C1. Okay. Now what I'm doing, I'm transforming this, and I try to get back to original C1, C2, C3. If I'm able to get, that means determinants are same, right? Is that clear? Okay.
Yeah.
So yeah. So for that, what I do, I'll take this, and we want to get rid of the C2, right? So for that, we can subtract column this column. Okay, I'm saying column one. We cannot see column one. I'm directly saying I'm subtracting this one from this. So I get C1 minus C3 here, and C2 plus C3 here, C3 plus C1 here. Okay. Now in the next step, what I'm doing, I'm taking this column and adding into this one so that I can get rid of C3. So I will get 2C1 here, C2 plus C3 here, and C3 plus C1 here. Okay. Now in column 1, I can take 2 outside. Okay, no problem. C1, C2 plus C3, and C3 plus C1. Okay. Now, so I got this C1. Okay. Now next what, to get rid of this C3 from here, I can subtract C2. I can subtract C3 from, I mean not C3, this entire one from this. Okay. So what I'm doing, C2 minus C1 plus C1, and here C1. Here is a
Sir,
two term. Okay.
so just wanted to ask something. So basically,
Hmm.
the moment we are pulling out the two, in case of
Hmm.
matrix, so if you pull out the scalar,
Yeah,
so
no, this is not matrix. This is not matrix. In matrix, we cannot pull out this just one
yeah,
column.
this is
In
the
determinant, yeah, in
determinant agent.
determinant,
Yeah, yeah.
yeah, in determinant only. Okay,
Okay, okay. Thank
okay,
you.
okay, okay. Then this we got. Now what we do to get rid of this C1, we can add these two. Okay, these two. So what we get, C1. Then we add this. C1 will be cancelled out. Here we get C2 plus C3, and now here it will be C3 plus C1. Okay. So see, we are not able to get reach where we want to. We again back to this one. Okay. Is that clear?
Yes, sir.
Sir, I have doubt in
Yeah.
practice assignment, sir.
Okay. Yeah. So for this is the question number 8. Okay. This is question number 8. There is question doubt in question number 9 also. So choose the
Yes, sir.
set of correct options. Determinant of A3 cannot be determined from the given information. This question is actually related to this. Yes, 8 and 9. Determinant A3 cannot be determined from the given information. What is A3? Yes, this is true. Uh, Set of correct options. What is
But I
A3?
said determinant of A3 would be 0, na? Because one column is entirely 0.
Okay. Sorry. Yes. So in A3, one column is entirely zero. That means determinant is zero. So that's why this option is incorrect. Yes, determinant of A3 is zero because one column is zero. Okay. We can open that determinant using that column. Determinant of A4 is 2 times the determinant of A. Okay. So determinant of A4. Yeah. So what we get actually in determinant of A4. Yeah. Here we are calculating determinant of A4. So I think we have applied the same condition 2 times. Okay. So at this step, everything is clear, right? We have just subtracted column from column 2, column 3. Okay. So here C3 will be cancelled out, C2 minus C1 we get, and okay, this is that. Now what we do, instead of this one, we add this to this. Okay. So what we get?
Sir,
C1.
rather than adding those two, can't we add C1 with C2 minus C1 so that we can get C2 only?
Okay. That's what actually we did in the last. So that's why we, because I just forget about this. These two terms are different. Okay. Yeah. So
Sir,
we
is
want
there
to
not
just get.
any other method to solve this type of question? Like we
No,
have to
this
find
is,
determinant now.
yeah. This is the only method. So we, what we do, we can add these two. Okay. Basically, we want to get rid of the extra terms. Okay. So here C1 is extra. So how can we get rid? By adding into this. Okay. So when we add into this, we get C2. Okay. uh, this add into this one, you get C1. Here C3 plus C1. Okay. Now we want to get rid of this C1. How to do this? We can take this and subtract this one.
From
So we get
column one.
C3. We get C3, C2, and C1. Okay. So clearly this is 2 times the determinant of A. This is the determinant of A. Okay. So
So please hold on for a second.
just I'm repeating again what I've done. I've taken this. I've taken this one. Okay, C1 plus C2, uh, and then where I started from here, right? Yeah, this one. So this is C1 plus C2 and C2 plus C3 and C3 plus C1. This is the actual term. This is A4. Okay, so from here I have started. Now I have subtracted. Okay, these two, and then I got this step. Then after that, this is 2C1. So taking 2 outside, then we get this, and then after that we have just added these first two, so I can get C2, and then subtracted first column from the last one, so we get C3.
Sir, actually I am copying the solution.
Okay.
Please write up, sir.
Anyway, I will share this slide in the folder. Okay, there you can get the notes from the instructor. There only I will. Oh, sorry, not with the instructor. Different for TA notes. Okay, I can share.
So we will upload. It will be uploaded on the dashboard or on the folder. Folder, right?
Not dashboard.
Folder.
Only in folder. Yeah, that is already I think shared with you, right?
Okay.
Sir, I have to write only 2 steps. Please open that again. Yes, sir, done.
Yeah.
You can finish it now.
Okay. So this is the question number 9 of activity 2.3. What one?
Yes, 2.1, I guess.
2.1.
2.1.
Yeah.
2.1. Question number 9. Okay, A4 is C1 plus C2, C2 plus C3, C3 plus C1. We are writing, okay. Second step, we are using these two, subtracting. So C1 minus C3 and C2 plus C3, C3 plus C1. And then in the next step, I'm just subtracting these two. Or no, not these two. I'm adding these two. Then I will get. I'm getting 2 times C1, C2 plus C3, C3 plus C1. And in the next step, I'm just taking 2 outside, C1, C2 plus C3, C3 plus C1. And then for this, I'm subtracting this from this. Okay, and I'm getting C1, C3, C2 plus C3. And next step, I'm subtracting this from this. I'm getting C1, C2, C3. Okay, this is the determinant of A. Okay.
Sir, I have a question. Can you go back to the whiteboard where you were explaining?
Okay, 1 second, 1 second, just one. Okay, yeah. So which question?
The same one which you were explaining now. Can you just go back to the whiteboard?
Okay.
Okay. So here, I understand the whole steps what you just gave out over here, but the question which I wanted to understand is the first step A4 says C1 plus C2, C2 plus C3, and C3 plus C1. So one of the property is like if we are adding multiple of another column or a row, then the determinant will be zero, right?
Multiple of another column. So I'm not adding any multiple.
C1 plus C2 plus C2 is a multiple of another column, right? Basically, column C2. 1 into
In which
C2.
actually
The first
there
step,
is no. Hmm, hmm,
the A4, the way it has been written is C1 plus C2, right? So the plus C2 is basically adding multiple of another column to the column C1, right?
Yes, yes.
Yeah, similarly for the next one is C2 plus C3. So you are adding multiple of C3, which is 1 into C3, right?
Hmm,
Similarly,
hmm.
1 into C1 to the third one.
Okay,
Now
okay, okay.
the point what I'm trying to think is when it is a multiple of another column, then the determinant automatically becomes 0. So, why I'm not able to apply that.
No, no, actually,
So because we cannot reach this system of equation just from C1, C2, and C3. There is no such linear combination that will ever happen after performing those linear combination. It is just given to us just to ask whether this is going to have any relationship with A. This is the question over here.
yeah. So what you are saying that determinant should be zero. So this is not the condition for determinant zero. Okay. A condition for determinant zero is something different. Like suppose two columns are same, or maybe one column is zero. Okay, these are the condition for determinant zero. So
So
here
there is,
there are.
yeah, no, I understand. So two columns are same. You are right, and then, there's one full column or a row is 0. Yeah, adding that these two things, there is one more. If you have one column which is multiple of another column, then automatically the determinant becomes 0.
So but there is no column multiple of another column. Can you find any two column which are multiple of each other?
That's what I was saying. Like the
No,
first
there is
one
no
here.
column. Yeah, the first column,
So
okay.
basically, he is getting confused by saying that the whenever we say that there is a linear combination, the determinant would remain the same. So basically, if determinant is zero, then the entire thing should also become zero. That's what his problem
Yes,
is.
yes, yes. Yeah, okay. But initially, determinant is not zero. See,
Yes.
and in question number one, where it is said that determinant is zero. This is just C1, C2, C3, not zero. Okay. So because this matrix don't have determinant zero, okay, then how can this A4 can have determinant zero? Because A4 is just uh, after applying this, and so not we don't have any relation between A and A4, but their determinants is just actually related. Determinant of A is just half of the determinants of A4. Okay?
Okay, so the way I'm trying to put forth is the A1 is zero,
Hmm.
only because
Oh, okay.
A1 is
Why?
zero only because C2 plus 5 C2, right? C2 plus 5 C2, right?
No, no, not zero. Even why are you thinking even is zero? No zero.
A1 is equal to A. The question says that.
Yeah,
Just
yeah.
check.
Not A1 is equal to A. Determinant of A1 is equal to determinant of A. A1
Okay.
and A are different matrix.
Correct.
Okay.
Determinant of A1, what it would be like zero.
It would be no. It would be same as the determinant of A, the original.
Okay. Yeah. Thank you. Okay.
That's it.
Sorry, Ravi here. I just joined late. I have one basic question. Can you go to the whiteboard what you explained? In that one, there is one step where you are taking two common outside, right? So
Yes,
in this
yes.
one, two C1, C2 plus C3, C3 plus C1. So here, how you are taking two common out of all this thing?
Okay. Now clear. I'm not taking. Before I just written A4. Now it is just determinant of A. Okay. These are state columns. Yeah.
Okay.
Okay.
Sorry. Okay. Yes, sir. Yes, sir. Now I got it. Now, yeah.
Okay. Okay, they are determinants only. So in determinant, we can take any scalar out of the
Yeah. Yes. You're right. You're right. That I agree.
okay one column only. Okay,
So can we take out any scalar out of a matrix? No, na?
no. Actually, that scalar should be multiplied in each entry.
Each, sorry,
Uh, Each entry. Suppose there are
each element.
each element. Yeah, that
Yeah.
means
Yes,
there
sir.
are.
Please explain this concept once.
If this is a 3 by 3 matrix, and if it is a matrix, okay. If it is a 3 by 3 matrix, okay. Then if you want to take out anything common, then that's so in determinant if it is just t multiplied in first row, we can take out in determinant. There is no problem. Just determinant becomes t times. But in matrices, this in order to take this common, t should be here as well, here as well.
Else we'll
Then
have to, else we'll
yeah,
have to divide.
So you mean,
then we can write a b c d e f o r.
so this is in determinant, right? Or matlab
No,
matrix
no,
mein?
no, no. This is matrix.
Yeah, okay.
For
And
matrix.
if we take common in determinant, then that scalar should be multiplied with that only one column or row.
Yeah, in that case, this determinant of this matrix would be equals to determinant of this A, B, C, D, E, F, G, H, I times T, Q. Okay, from each row we
Okay,
can
okay.
take. Okay,
Okay, sir. Got it.
for matrix this for determinant T times T Q times, and here it is T times. Okay. Now, okay, can we move? Okay. So next,
Uh, uh,
any other, yeah, any other doubt?
Yes, sir. I have a doubt.
Hmm. In this
Sir,
activity,
in the question 9,
this is nine question number nine.
can you explain again it?
Again, oh, actually, I have explained two times. See this one. This is the entire question number nine. So what I have done is, yeah, I have taken this A4. Okay. Okay. So what is question nine here? Question nine says a set of correct options. So we have to calculate the determinants. So here it is saying determinant of A4 is two times the determinant of A. Okay, this option. Option number third. So let me check. So what is A4? A4 is C1 plus C2, C2 plus C3, and C3 plus C1. And then I have added these two, the first two. So I got and replaced the first column. So not added, I have subtracted this one from this one. I got C1 minus C3. Okay. And then I have take this and added both. So I got 2C1. And then we can do this actually without changing the determinant, right? And now I'm taking 2 outside. Now determinant is 2 times the previous, this one. Okay. And now it is C1, C2 plus C3 and C3 plus C1. So now I have actually taken this one and subtracted this one. So I got C3. Now I have taken this one and subtracted this one. Now I have C2 without changing the determinant. Okay. So at the end, determinant is 2 times the this one, determinant of this one. So what is the determinant of this? Determinant of A. Okay.
Okay, sir. Now it is clear.
Any other doubt in this activity?
Sir, practice assignment, sir.
Question 10, sir.
Sir, activity
Question.
2.
Okay, question 10 somebody says. Okay. So it is asked, this is a 3 by 3 lower triangular matrix. Okay, lower triangular matrix. And then roots of the equation determinant A minus xi equals to 0. Determinant of A minus xi equals to 0. So what is this? A is a lower triangular matrix, right? So what is A? I'm assuming, okay, A, B, C. These are 2 by 2 or 3 by 3? 3 by 3. A, B, C, D. Okay. Uh, Lower triangular, okay. That means these entries are 0. Here we can say E. These are lower triangular or diagonal matrix. If a diagonal entries of 3 by 3 lower triangular matrix A is 1, 2, 3. Sorry. Okay, diagonal entries 1, 2, 3. And there are some entries A, B, okay, C also. And this is 0. So this is A minus x times I. 1, 0, 0, 0, 1, 0, 0, 0, 1. And then determinant of this equals to 0. So what is this? I have written correct. So basically,
You can subtract and multiply the diagonals.
okay, and these entries are as it is. Okay, A, B, C, whatever, same. And then determinant of this is equals to 0. Okay. Then what will be the determinant of this lower triangular matrix?
Diagonals multiply.
Product of the diagonal.
Minus x 2 minus x.
This is the determinant of lower triangular matrix. And this is equals to 0 determinant. Okay. Now we have to calculate. What is the what we have to calculate? Sum of roots. Okay. What are the roots of this equation? 1, 2, 3. Okay. So sum of roots is 6. Any doubt in this now?
No, sir.
No.
Okay. Next question.
Activity 2, sir.
Hmm. Question number.
Fourth.
Question number 4. Consider system of linear equations equal to where A is this, X is this, B is this, and the solution of for X is partially known. What is the value of A square if A is given? And observe that second row of the vector X is given as 0, which implies X2 is known. Okay, uh, so what we have to do here, we have to find the value of A square. Okay, we have to calculate. The solution is partially known means okay. Actually, this problem of writing. That's why you have to take this screenshot. Okay. So solution is partially known. So for solution, just I want to make sure you know Gaussian elimination, right? And you have watched the lecture.
No, sir, I don't know.
No. Also, don't watch the Gaussian elimination lecture now.
Then how would you use this?
This
Using
is
Kramer's. I think Kramer's rule is enough. I think.
yes, sir. This is activity 2 question.
Sir, here we can simply create the equation and solve the A. And after that, here he given A square.
Yeah, so basically catch here is this x2, I think x is partially known because x2 is already 0, right?
Yeah.
X2 is already 0. So for x2, we can say satisfying this 0, right? So what is x2 in general? According to Kramer's rule, ax2 divided by determinant of a, right? So what is the determinant of ax2? What is ax2 first? What is ax2? Ax2 is determinant of this matrix, right?
Yes.
1 a 1
Zero,
and
zero.
sorry 1 0, replace this with b and 0 2 a, right? This is the determinant. So what is the determinant? So I am opening with this, so plus minus 1 and minor of this matrix, this entry. What is the minor of this entry? We delete this
A,
one,
A
we delete
square
this one,
minus 2.
A square
a
minus.
square minus, so we basically 2 minus a square. This is the determinant of this one. What is the determinant of a itself? So for that, just I simplify a little bit. uh, what we do, we can take, okay, don't simplify, just directly open it from the first row. Okay, one, so a and minus a square minus 2, right? So determinant, this is this we got a minus a cube plus 2a, right? This one, am I right?
Yes, sir.
Okay, so whatever it is, basically this is 0, right? Because we already know. So that means numerator is 0. 2 minus a square is 0. That means a square equals to 2. Okay. So what is the value of a? Sorry, a square is actually answer. It is 2, right? Is that clear?
Yes, sir.
Sir, one
Yes, sir.
actually I have solved it, but not this way. I have created the equation and find the value of a and square it. Is it okay, or we can go this method?
Actually, we should go by this method because
Yeah.
we used Kramer rule here because the value that satisfy this system for x2 variable is already known. But according to Kramer rule, it is equivalent to this, right? Equal to this. So basically, this has to be 0. So what is this? This is the determinant 2 minus a square, which is has to be 0, then a square should be 2. Okay. So no need to no need to do anything. But this question is designed so that you know Kramer rule. Okay.
Yeah, yeah.
Yeah. Next question.
Sir, how to solve fifth one also?
Consider the system ix equal to b. A is this, x is this, b is this. Then solution for x is partially known. Uh, okay. Again, the
No,
second
sir, just
variable.
writing it.
Okay. Okay. Second variable is 0 basically. That means ax2 should be 0. Determinant of ax2 should be 0. And so what is the determinant of ax2? 1, 3 plus 2. Okay. 1, 3, 8 plus 2. And then what is b? 1, 1. What is the determinant of this? This is ax2. Determinant of this is 1 minus 3a plus 2, which is, and this should be equal to 0, right? So that means 3a plus 2 should be equals to 1. 3a should be equals to minus 1. A should be equal to minus 1 by 3. Okay. It is asked 3a only, right?
Okay,
So it
sir.
is minus 1, right? It is minus 1. So these two questions are same basically. This step is not needed.
Sir, why did we take AX2 as 0?
Because
Determinant of AX2 as 0.
this in this x, see this x vector is
Mm-hmm.
x1 0, x1 0. That
Yes.
means second variable is 0. So that is satisfying the system. Second variable is 0. So using Kramer rule, what we do, we just find the variable that satisfy the system, right? Solution. So 0 for the second coordinate is always satisfying this, right? So that's why we just calculated this one, because solution x2, the variable x2, solution variable, okay, solution x2 should be equals to ax2 determinant.
Excuse me, sir.
Yes.
Sir, here it is written x2 is equal to 0, na?
Yes.
So it is not necessary that ax, matlab determinant of ax2 also 0.
Yeah, it is not necessary, but what I'm saying is how to find x2 using this, right? This is clear.
Yes, sir, we can find this.
Okay. And x2 is 0. Okay.
Yes, sir.
That means when this expression is 0, when numerator is 0, because denominator
Okay,
cannot be
sir,
0.
got it.
So only numerator should be 0. This is the numerator, not ax2. This is determinant of ax2. Next question.
Sir, practice assignment 271, sir. Sir, 7, 1 and 8, 9, 10 also, sir. Sorry, sir, ninth and 10th one. 7, 9th and 10th.
Okay. Uh, Consider the system of linear equation ax equal to b, where a is this, x is this, and b is this. The solution x is partially known. What is the value of a if a is greater than equal to 1? And this question is again same, I guess, right? Can you tell me? I just solved two questions. Do you have any idea how to solve this now?
Sir, I am bit confused in this term. Means I am not getting how to solve, sir, this.
But I just now I actually solved two questions based on the same concept. You can see x is partially known. How? because we know x2 is 5 by 4, right? Are you able to see this? X2 is 5 by 4.
Same Kramer's rule we
Yeah,
can
yeah,
solve
yeah.
that.
Yes, yes. Using Kramer rule.
Yeah.
So whoever asked the question, are you able to see x2 is 5 by 4 here?
Yes, sir.
Okay. So just construct the matrix. Okay. Just tell me the first column of the matrix that is given here. What is the first question? First man.
Hello.
First
Uh,
column is 2a minus 1.
Excuse me, sir. This is Paul this side.
What?
Second column is a minus 2a.
Am I audible, sir?
Don't. Yes, yes, you are audible.
Yeah. So I have another session right now. BA session. Can I just drop off?
Yeah, yeah. You can drop.
Thank you.
Okay, my voice is clear or this is repeating actually?
No, sir. Now it is clear, sir.
So 2a minus 1, and we are finding ax2, right? So that means second column will be replaced by b. So 1a1, right? I'm writing determinant for this ax2. Okay. What is third column? 3 minus 1 0. Up to this part is clear or not? How
Yes,
I
sir.
construct?
It is clear.
How, yeah, okay. Okay. So what is x2? X2 is determinant of this divided by determinant of a, right? Is that clear?
Yes, sir.
You using Kramer rule, and this is equals to given 5 by 4. Now,
Sir, but why we 1a1 took in second column?
because this is the definition for constructing this ax2 matrix.
Okay, sir.
Okay, using Kramer rule. Just go back to the slides and just see why. What is Kramer rule?
Yes, sir. Yes, sir. Got it, sir.
So now just solve this. You have to do determinants. Okay, divide them and equal to this equation. You can find the value of a easily. Okay.
Sir, just a second. Let me took a screenshot, sir.
Can you just show the original matrix once?
Okay.
Done, sir. Thank you.
Question number 7.
Sir, question number 9th and 10th also, sir.
Okay, so this is a very big question. I'm just solving. Uh, I will not be solving the entire question. What I can do instead, you guys solve the question, and I'm here. And if you have any problem, I'll tell you. Okay. So before solving, I'm just can give you a hint. If you have any problem, you can ask me directly. Okay. So all of you, whoever. So how many of you have not attempted this question? Just raise your hand. Not attempted. Just quickly raise your hand. Okay. So yeah. So there are enough students. Okay. Just take some time. Take it as a break. Okay. Maybe 5 or 6 minutes. Okay. After 6 minutes, I will discuss this. If you don't get. Okay. So question is this. So on this question based is I think question number 8, 9, 10. Three questions are dependent on this basis. Okay, just try to see this. After 5 minutes, I will discuss. Okay, we are taking a break. Okay, so let us discuss now. Uh, all of you attempted this question.
So 2 more minutes.
Okay.
Not getting, sir.
Okay. So now let's discuss this. So first of all, what am I audible?
Yes, sir.
So what is the question? So who asked this question? Is that guy here?
Yes, sir. I had.
Okay. So do you understand the question? What is the question?
No, sir. I'm means a bit confused in that, sir.
Okay. So this is, I think, this may use Gaussian elimination or maybe something. I'm not sure, but let's see. So basically, this is some I can say some variable. Okay, RR. Okay, just don't read this. I mean, if you have time, just please read it. Otherwise, no need because everything is given here in this matrix. Okay, so these are three variables: RR, capital RR, and capital R, small r, and the small r. Okay, and this is given here. Uh, so basically, 1 0 0, 1 by 2, 1 by 2 0, and 0 1 0. This is nothing but the coefficient matrix. Okay,
Yes, sir.
and what is B here? What is B? Do you know what is B? I mean, AX equals to B. So what is B?
Don't know, sir.
What is this? R 1 by 2, 1 by 2 0.
B.
We can find the b from the formula which is given px n minus 1 is equals to x.
Uh,
So the right one is the b if we put n values of n as 0, 1, 2.
hmm. Okay. Yeah, X naught is actually this one. Okay. So we can find actually B. Yeah, C is correct. Okay. So in question number 8, any doubt?
No,
Sir,
sir. No doubt.
here
So
meaning x, just sir, x not equal to x10. What is the meaning of x0?
what is the meaning of?
No, no, in question, same question, sir.
Yeah, yeah.
The, here, sir, x0 equal to x10, x20, x30. Uh, Meaning of x01, 1020 means what he's saying.
Yeah, yeah. This is actually this 3 cross 1 matrix, which is B. Okay.
Okay.
So which is given here, and this is coefficient matrix, which is P. Okay, and there are three variables
Sir,
corresponding to
what
the.
is meant by they have given here, sir, x0 is equal to x01. This 01 means
Yeah, so basically, this is the initial state at time t equal to 0. 0 means, okay, the subscript one. Okay, understood?
Yes, sir.
Not.
In
So
this case,
basically,
sir,
yeah,
B will.
if you want to understand the real question, then you have to just read this, okay? Otherwise, for this course related thing, you have everything basically. You have coefficient matrix, which is P, and you can construct this X naught, which is B, okay? There are multiple systems, okay? Multiple system. So at time t equal to 0, what we do, we put this subscript 0, and then we get this matrix, this vector x naught, okay? And how do we get that? We can get this by this formula: p x n minus 1 equals to xn. So
Sir, what is n here? What?
this is
And
at time t equals to n, this vector, okay?
So
Sir,
this
can you
X naught
just
vector is
show
basically
an
the variable
example?
vector, right?
Okay, let me explain this. So in general, what we do, ax equals to b, okay? This is the system that we solve, okay, for x. Is that clear? What is x? X maybe is like x, y, z. Suppose three variable. Okay, and A is a 3 by 3 matrix. Is that clear? This thing? Okay. In this question, what is happening here? We have multiple systems like B1, B2, B3. This keeps changing. Okay. So how it is changing according to this one. So B1 is suppose this x0, and then B2 is suppose x1, B3 is x2. So whatever is asked in the question, we take that corresponding system and solve for that. Okay, now it is clear.
Not
Okay,
understood, sir.
Sir,
yeah.
this X naught, this X vector will be the variable vector, right? It won't be the B vector, right?
No, variable is this.
Okay, okay, okay.
R,
Understood. Got it,
yeah.
got it, got it.
The variable. This is the B vector at time t equal to 0. Okay, at time t equal to 1, the vector would be x11, x12, x13. Okay.
At time t equal to 0, what would be the vector? X10.
Yeah, this one, which is given x0. And at time t equal to 1, this is x1. At time t equals to 2, x2. Similarly, at time t equals to n, at time t equals to n, it would be xn. Okay. So basically, this is how we get different systems. Okay, by changing the b vector. Okay. So now this is the question. So first option is just asking about row echelon form. So it is clear. If anyone has any doubt, he can ask. In the
No,
second
sir.
option, suppose 2 years of the distribution vector, that is x2, is calculated to be this. So x2 is given here, and the initial distribution of RR is 1 by 3. What is the meaning of initial distribution of RR is 1 by 3?
Sir, at
Don't know,
time
sir.
t is equals to 0, the initial value of RR is 1 by 3. That is x0 subscript 1
Yeah,
is equals to 1 by 3.
very good. Okay, so RR, so there are three variables as I told you, RR
Sir, I am
and
not
this.
getting. Can you write and show?
Yeah, I will solve. Okay, so basically initial distribution of RR is 1 by 3. That means, what is initial distribution first? X 0 1, x02, x03. This is the initial distribution. What is the initial distribution of RR? Sorry, capital R or small r?
Both,
Initial distribution
all
of
are
capital R.
equal.
That means, so this is corresponding to capital R, and this is corresponding to this one. This is corresponding to this one. So actually, we have given this one, initial distribution of RR. What is this? 1 by 3, right? So this is known. Is that clear up to this part?
Yeah.
Yeah.
Okay. Okay. Now x2 is given. So, or now it is asked what is the initial distribution of other two. Okay. So first of all, what we do, we take this x2. Okay, tell me what is x2. What is given here?
3/4.
3/4. Next, 1/4 only. Okay, so this is given here. And what is the relation between the p and x distribution vector? Relation is this
Px plus
p times n minus 1 x n minus 1 equals to xn. Okay, and what we need x naught, and we are given x2. So what we do? So one way we can do, yeah,
One time we'll put n equals to 0, and one time we'll get a relation x2 equals to p square x0.
x0 equals to
No sir, x2 is equals to
x2 is equals to
p square x0.
x0. So, but okay, I got it. What you are saying? Yes, 1 2. So basically, we want x2 here.
x
Okay.
square x0. Yeah.
So we write p times x1, right? And then we write this p times x0. Okay. So basically, that's why this is how we get p x0. Okay. So we have p. Okay. We have p. P is given in the question, and x2 is given in the question. Then we can get from this actually expression we can get x naught. Okay, so when once we get x naught, uh, we can we can have these two values. Okay, whatever given, I mean these two values. Okay, is that clear or not from this? Are you able to solve from here, or I will solve? Everything is given here. P, you know, you can find p square, and x2 is given here, this one. Okay, I think you should be able to do. So whoever asked this doubt, is that clear?
Sir, you have already done AQ 2.5, question number 8, I believe.
No, no, no. I will solve after this.
Okay, sure. Thank you.
Okay, so and doubt, should I move ahead?
Yes, sir.
So, so this question is clear because you can find the distribution of both. So, okay, very easy. Question number 10. What is in the question number? Suppose after 3 generation, the distribution vector, that is x3, to be calculated as 1 0 0. And recall that this is 0 to 1. Find out the correct set of options. Okay, so x3 is given. So using that, so okay, x3 is given. X3 is given 1 0 0. Okay, and we have to find x naught. That is the question, right? Yes. So same thing we will do. X3 is p times x2, right? And then this is equals to p square times x1, and this is equals to p cube times x naught. So again we got the expression. Now we can get x naught. Okay, is this right expression correct?
Yeah.
Okay. Yeah,
So,
just solve
so,
by.
so P, that P, we have to multiply it because it is P cube. So that P matrix has to be multiplied by itself by 3 times, and then we have
Yes.
to calculate it. So
Yeah.
there is no shortcut to that one, right? We have to
This
physically
is actually,
multiply.
yeah, this matrix
Okay.
is actually easy because there are lots of zero. One, two, three, four zeros,
Okay. Yes.
and
Yes.
and
Okay.
and
Okay.
and two ones. So it is very easy. Value multiply very easy.
Okay. So
You will see.
basically, after
You will
final
see.
multiplication, we will come to the value of RR, and RR, right? That's
That's it. So basically, this is as I told, this x naught is at initial time t equal to 0, and at t equal to n, this is there. Okay.
Sir, in question number 8, second option, that the row reduced echelon form of P and P square.
Okay. Okay. One second. One second. Okay. Yeah. Yeah. Which question you are asking?
That question number 8, the last one, which we did. Question number 8, second option. The way we concluded the row reduced echelon form of P and P square are same in the case. So we have to first calculate P square and then compare it, right?
Yeah.
Or
Yeah. Yeah.
is
Yeah.
there a
Yeah.
way?
Yeah. It is very easy to calculate. P square is
Okay.
very easy to calculate.
Okay.
Okay. Okay. So this question is done now. Which which question somebody asked? 2.5. Yeah.
Yes, sir. 2.5, question number 8.
Is it related or independent? Independent, right?
Yeah.
Yeah, A is a 3 by 3 real matrix whose sum of entries of each column is 5, and sum of first uh, two elements of each column is 3. Okay, then which of the following statement is true? So we have to tell about the determinant. Okay, let me take this screenshot. Okay, so okay, are you able to construct the matrix or not?
Yes, I was able to.
Yeah, so what was the, so it is saying every column has such entries. The sum of the each column, no, sorry, sum of entries in each column is 5. Yes, each column has I mean sum is 5, and sum of first two element of each column is 3. If this, suppose this is A, then this is 3 minus A, right? Then only this will be 3, right? If this is B, then this is 3 minus B. If it is C, then it is 3 minus C. Is that clear?
Yeah.
Okay. And sum of all the, so this is a 3 by 3 matrix. Okay. And so last column, there is a one more actually row. So because the sum of the entire column is 5, then what should be this entry?
Yeah.
What should be this entry? This one?
Said 2.
2. Then only
Two.
it will make 5. And so what is this entry? 2 again.
Yeah.
All two.
So are you able to find this matrix A?
No, actually, um, yeah, I didn't write this way.
But now you are satisfied with this, that this is A actually.
Yeah.
Okay. So as the given condition, as per the given condition, the sum of the column is 5. Sum of the first two entry in each column should be 3. This is satisfied, right?
Mhm.
Okay. Now just try. You will be able to solve this. I
Yeah,
mean,
sure. Yeah, I'll
to
try
find
that. Okay.
what the determinant of A you will be able to see. Okay. So what you have to do is actually apply the operations, because Basically, you have to talk about the determinant. Okay. So
So,
yeah.
so in this question, I'm having doubts in the options because we can somehow make two rows equal.
Hmm.
So the determinant should be 0, but no such options have been given.
Yeah. See. So what you are doing? Row two. What can you repeat? What you are doing? What you are saying?
I'm saying that we can make two rows equal.
Oh, I don't think so.
Sir,
See.
if we want to take determinant, so what I'll do is I'll multiply the row 3 by 3 by 2 or minus 3 by 2 say,
Hmm.
and then
Row
I'll add it to the row 2.
Okay.
So I'll get minus a minus b minus c in row 2.
Just whatever you are saying, just try to do. I am. I'm sure you will not get. Okay.
Okay.
Just try to do, but try to do. Try to do. See now what I'm doing. Trying to do R2 minus R2. Sorry, R2 plus R1. Okay. So what I get in place of R2? 3,
Everywhere it will
3,
be 3, sir.
3, 3. Okay. Okay.
We
Row
will get 2
operation
common
ending.
from the third row and 3 common from the second row.
This is okay.
So the
And
determinant should be 0, na, sir?
A, B, C. Yeah, you are right. Hmm. Yeah, where I'm doing mistake actually. So sum of entries in each column is 5. Yes. Uh, and sum of first two elements of each column is 3. Okay.
It's saying sum of first two elements only, right?
Yeah, sum of first two element in each column, and whose sum of entries of each column is 5. Okay. When I will add these two columns by finding the determinant of A. Okay, sorry. Why we are saying that this is incorrect? Yeah, we are correct. Determinant is 0 definitely. Okay. Now I'm just saying determinant is 0. Okay. Why? So that is actually we doubt ourselves. Then actually sometimes so determinant is 0 definitely. But determinant of A is multiple of 5. Is the 0 multiple of 5?
Yes.
Okay, yes. Somebody might find it difficult because in the previous sessions I saw this. So I'm just asking simple question. Is 15 a multiple of 5?
Yes. Yes.
Yes. Yes. How do you know? You can write 5 times 3
Three.
equals to 15. That means 5 is, 15 is multiple of 5, 3 times, right? Okay. Similarly, I'm asking, is 0 a multiple of 5? I'm saying yes. That means I can write something. 5 times something equals to 0. That means 0 is multiple of 5. And what is that? This is 0, clearly. So this is an integer. That means integer times 5 equals to 15. That means 5 is multiple of 15. Similarly, integer times 0 times 5 is equals to 0. That means 0 is multiple of 5. Okay, so first option is true. Similarly, all the
All
options are
option
true.
will be true.
Okay, any doubt?
Okay, so this was the trick.
Yeah.
All options correct.
Okay. Okay, so any other doubt? Okay. If all the doubts are solved, then we are ending the session because it is just 10 minutes now. If anybody want to ask any question, he can ask. C can ask.
In general, I just wanted to check with you on the verbiage. Like if there is a system of linear equation and we have, let's say, infinite solution, then the verbiage would be if there are multiple options, it would be like the solution is not unique. Whereas if it is no solution, then it would be cannot be determined, right? Am I getting
Yes.
this right?
Yeah,
I
yeah,
mean,
yeah.
this is the way both are different, infinite versus no
Yeah,
solution.
yeah. Yeah, yeah. Infinite solution is completely different from no solution. No solution means there is no common point exist.
Yeah,
Infinite solution means there are
no,
infinitely many points common in
correct.
the.
Yeah, I get, the three options, but what I'm trying to understand is the verbiage.
Yeah, yeah. But we is clear that if suppose there is a system given and you are asked to find the solution. So yeah, if you are getting no solution, that means no solution. And if you are getting exactly one solution, then you can say unique solution. And in other case, you will say infinite solution.
Thank you.
And three possibilities are possible only. I mean, if I say if a system has more than one solution, what I'm trying to imply, I'll say a system has two solutions. What I'm trying to say,
Infinite. Yeah.
infinite solutions. Yes, and this thing will clear as you go further in the course. I mean, after Gaussian elimination, a lot of things will be clear. Most of the things. Gaussian elimination is the actually key point here. Okay. Okay, so if you don't have any doubt, then only I'm just doing one example of Gaussian elimination. Okay, you don't have any doubt. So what is Gaussian elimination? Just take a simple system. Mm. 2x1 plus 5x2 equals to 3. Okay, and 6x1 plus 3x2 equals to 1. So these are two lines, okay, and we can say this is system A, x equals to b, where A is 2, 6, 5, 3. Okay, how many guys are there in the meet now? 16. Okay, and this is A, and what is x? X1, x2, two variable. What is b? 3 and 1. Okay, so we are asked to find the solution for this using Gaussian elimination. Okay, so what are the possibilities? No solution, infinite solution, and unique solution. Okay, unique solution is possible only implies that determinant of A not equal to 0. Okay, in these two cases, determinant of A equals to 0. Is that clear?
Sir, has to be zero or it can be zero in the
Has to be
first two
0.
cases?
Yeah, has to be 0. Determinant has to be 0. Okay, so so that means unique solution. That means determinant is not equal to 0. Then only there is a unique solution. So then somebody say just find the unique solution. So what do we do? Use the Cramer's rule. X1 is equal to ax1 determinant, because determinant is not equal to 0, and this is the solution. Okay, no problem. Using Cramer rule, handle the unique solution part. What happens if there is no solution or infinitely many solution case? Okay, so after this is system 1. I'll solve one more system for infinite solution. Okay, but this is a case of unique solution, so we can directly find using this. Okay, but still I'll use Gaussian elimination for illustration. Okay, so how to do this? How we form a matrix, augmented matrix we call this. Okay, What is this? 2, 5, 6, 3, 3, 1. Is that clear? And Gaussian, this elimination method says the solution for this system will be equals to this system. What is this? Here, this matrix is this is A matrix. Here, R is R REF. Okay, or RREF, row reduced echelon form. So this is the whole point here. Okay, so now try to convert this matrix A into RREF. Okay, so for that, this entry should be leading. Are you guys with me or not? Just say
Yes, sir.
something.
Yes.
So for converting this leading entry into leading entry, we divide this first row by 2. So first row 1 divided by 2, you get 1, 5 by 2, 3 by 2. So whatever we do here with this matrix, we do for this column as well. Okay, we just keep this bar, and after the row 2 is same as it is, but now we can subtract row 2. Okay, so I'm just doing a shortcut. Okay, just try to, I'm subtracting, okay, a row 1 from row 2 after multiplying row 1 by 6. Okay, so 6 times row 1 and new row 1, this new one. Okay, so 6 times this is, so this is 0, and 6 times this is 15, right? So 3 minus 15 is, what is 3 minus 15?
Minus 12.
Minus 12, and this is 6 times, right? So 6 times this is 9, right? So 1 minus 9 is minus 8. Okay, so I just applied the two operations together, and now what we do, because we have the leading entry now, we have leading entry in the second row, so we will divide the second row by minus 12. Okay, so in that case, what we get 1 and 8 divided by 12, 0, 1, 5 by 2, and 3 by 2. Okay, so now you can see this is REF, right? Are you able to find this? This is REF, leading entry, all things are satisfying. Am I right?
Yes.
Yes, yes, sir.
Okay. Now we expand this 1, 0, 5 by 2 just for because we are doing it first time, that's why. Otherwise, we just directly saw the solutions. Okay, I'm just doing it. Okay, and then this is equals to 3 by 2, 8 by 12. If we do it in reduced row echelon form, then we can directly actually row reduced echelon form. That means one more step, that is leading entry. So this is the leading entry. The rest of the entries are 0. This is leading entry, and this is not 0. So we can do one more step here in converting RREF. Okay, instead of expanding here, both ways are fine. Actually, we will able to find the solution x1, x2, and see. So just do this part later. First, see this one. So here what I am doing, take this column and multiply this. Basically these are two matrices. This is 2 by 2 and this is 2 by 1. So basically these two are same, so we can multiply them and we can get a matrix. So this x2, how do we get this x2? By taking this row and multiplying this. So basically this is 0, so x2 will be 0, sorry, x1 will be 0 and then x2 only. So x2 will be equal to this 8 by 12, that is 2 by 3, right? So this is x2, and what is x1? We take this and multiply this, so we will get x1 plus 5 by 2 times x2 equals to this 3 by 2. But x2 we already know, 2 by 3. So 2 by 3, that means 5 by 3. So x1 equals to 3 by 2 minus 5 by 3. Okay, so this is x1. So now we have solution. Okay, using Gaussian elimination. Now let's check from the Kramer rule whether indeed we are getting. So x2 is simple. So we are first getting finding x2. So how to find x2? Using Kramer rule, we find this matrix ax2. So ax2 is by replacing the second column by the b. So this is 2, 6. Second column is 3, 1. Okay. What is the determinant? Minus 16, right? Is that correct? Determinant of ax2.
Yes.
Okay. And what is determinant of a? Clearly, 6 minus 30. That is minus 24. So what is x2? But this is Kramer rule. Minus 16 divided by 24.
2/3.
And this is 2 by 3. Let me check whether x2 is 2 by 3 from guessing. Yes, indeed. Okay, similarly, you can check x1. So basically, this is Gaussian elimination that I told you. Okay, if I apply one more step here, if I reduce it instead of row echelon form to row reduced echelon form, one actually further. So what we get, we apply row 1 minus 5 by 2 times row 2. So we get 1, 0, and 5 by 2 times row 2. So this is 8 by 12, that is 2 by 3, and multiply 5 by 2 and subtract 3 by 2. So we get 3 by 2 minus 5 by 3. Okay, so exactly the same thing. Okay, so I'm just writing same here. So what I get here, 0, 1, and here I get 3 by 2 minus 5 by 3. Sorry, I this is the first place, 3 by 2 minus 5 by 3, and second this is same as 8 by 12. Okay, or 3 by 2, sorry, 2 by 3. Okay, so this is what you got. So you can see this is identity matrix because of the row reduced echelon form, and this is directly you have the solution of x1 x2 directly. No need to expand this. Okay, so this is the beauty of RREF. You directly have the solution exactly because this side, left side, you got the identity matrix. I hope you got the idea, right? Is that clear?
Yes, sir.
Okay. So this is Gaussian elimination. Now let's take one more system. System 2. An infinite solution case. Okay. Or no solution case also. So what will happen in no solution case? You just take one two parallel lines. Okay, I'm quickly taking. Okay, 2x plus 3y equals to 5, and 2x plus 3y is equal to 6. So clearly, these two are parallel lines, right? That means no solution. Is that clear? So what will happen when you do? We will apply row 1 minus row 2. Okay, what we get, 0, 0, minus 1, and 2, 3, 6, right? So so this is the 0 row, or we can multiply the second row by 1 by 2, so that, and keep it at the top. So this is 1, 3 by 2, 3, and this one, the first row, 0, 0, or we can apply multiply this by minus 1, so this is 1. Okay, I'm actually excluding some steps. Okay, but if you do it in detail, you will able to finally reach this. Okay, from this, no problem. So here, what you are seeing here, this side is 0 and this side is non-zero. 0 cannot equal to non-zero. So basically, what is happening here when you expand here. So this is some this is matrix. Okay, 1 3 by 2 0 0. This is x1. This is x2. This is 3 1. Okay, so just take this. Okay, try to get. So when you multiply this, so what you get? You get something. Okay, here, and but here you get 0, but here it is 1. Clearly you can see there is a contradiction. Here it is saying it should be 1, but here we are getting 0. That means no solution. No such x2 possible that can satisfy this system. Is that clear, everyone?
Yes, sir, clear.
Okay.
Yes.
And one more system, system 3, in the infinitely many solution case. That means 2x1 plus 3x2 equals to 5. And when it will be infinitely many solution case, then suppose this is 2 times 6x2
10.
equals to 10. Okay. Now if you do 2 4 3 6 5 10, this is an augmented matrix. Okay, now you reduce. So how to reduce? Row 2 divided by 2 and row 1 divided by 2. Okay, so one step at a time. Okay, so first row 1 is divided by 1, oh sorry 2, then 1 3 by 2 5 by 2. Okay, and this is divided by 2, so 2 3 5. Okay, oh don't divide row 1. Okay, row 1 keep as it is, 1 3 5. Okay, now these two are same, so row 1 row 2 minus row 1. Okay, what we get? 0 0 0 2 3 5. Okay, or we can divide row 1 by 2 so that we can get the leading entry 1. Okay, not needed here. You will see why it is not needed. Okay, because we are getting 0 here, so we anyway got the infinitely many solution. Okay, 5 by 2 0 0 0. Okay, so this is the case of infinitely many solution. Why? Because here this x2 variable is basically independent. This can be any k. K belongs to any real number. Okay, so what is happening here? We can take this, which is when we expand x1 plus 3 by 2 x2 equals to 5 by 2. Okay, and x2 is any real number, that is k, right? So x1 equals to 5 by 2 minus 3 by 2 k. X2 is k. Okay, so just keep changing the value of x2. So k, you can k any real number. Suppose k is 1 2 2 by 5 2.5 2.5. Okay, 2.3 2. Any real number you can take instead of k, you will get a different value of x1. Okay, so this is how you will have
So
x1
between x1 and x2, you have randomly chosen anyone to be independent, or is there a proper way?
proper way. Because what is the proper way? There's a leading entry in the first. Okay, there is no leading entry in the second row. Okay, sorry, second column. So we see leading entry column. So I'm writing this thing
Okay, that becomes the dependent variable.
for choosing the independent. Sorry, what I say? Yeah, dependent variable. Here we see leading entry columns. and uh, corresponding variables are determined. Okay, so here the leading entry is in the first column only. Okay, second column has no leading entry. Okay, so that's why second variable is independent. That is,
Yes,
we can take any key.
got it, sir.
Yeah, so this is just an introduction. Okay, don't see this. Yeah, I'm just doing too fast. This okay, but you just I'll upload this slide. If you have any help, you just solve some more question on Gaussian elimination, and in the next session on Saturday, we will do lot of questions on Gaussian elimination. Okay, no problem. Okay, that's it. Uh,
Thank you, sir.
so, okay.
Thank
You're
you.
welcome.
You.
Okay, you're welcome.
Good night, sir.
Thank you. Good night to all of you.